the topic is hydrogen supply from other sources than compressed gas cylinders. And the head of department Fuel Cell Fundamentals from Zentrum für Sonnenenergie und Wasserstoff-Forschung will head it, and give him a big hand and welcome here with me Dr. Ludwig Jörissen.
Excellent. So, good afternoon, ladies and gentlemen. I will shortly try to talk about how to supply hydrogen to decentralized fuel cell installations. We're looking a little bit on the fuels for uninterruptible power supplies. We look a little bit on what's available on the market in terms of fuel cell systems, and learn a little bit about fuel consumption, and then we'll have some short visit into a methanol and an ethanol reformer-based system. Now, fuel cells, well, you can say, please feed them well. Technically, fuel cells are something like electrochemical reactors, which are catalytically converting the chemical energy, which is provided by the fuel, into electricity and heat. But fuel cells are a little bit picky concerning their fuel, so only two fuels you can use directly in terms of to feed them directly, and this is first of all hydrogen, and second of all there's also a possibility to have the conversion of methanol directly. But in any case, both fuels need to be of appropriate purity, and they are sort of need some packaging. Hydrogen as a compressed gas is a lightweight fuel, but basically it's a bulky fuel. The containers are rather bulky and heavy. The fuel itself is light. Methanol is less heavy. However, you also need some packaging. The previous speaker already mentioned it. It has some issues concerning toxicity, and it has some issues that it's not really considered as a fuel, at least not in Central Europe. It's considered as a chemical, and so you have to minimize contact of people with the chemical methanol. Now, question is, if you don't want to bring bulky, heavy hydrogen on site, then you have to somehow produce hydrogen on site, and you can do that either by the reforming of alcohols or hydrocarbons. May it be methanol, may it be ethanol, may it be liquid gas, or may it be higher hydrocarbons like diesel. You can produce hydrogen on site by water electrolysis if you have surplus energy available, or you can use a solid fuel like sodium borohydride and hydrolyze it like zinc, as it has been done for ages in chemical laboratories to use acid to decompose zinc, or aluminum or iron. Now, so far fuel cell systems have been realized, quite a few of them, and fuels have been specified for that, and let's say solid fuels have not yet been specified. So we have the following specified fuels. It's hydrogen. There are some SAE regulations or some new ISO standards. There is methanol. There is a methanol water premix, and there is also propane gas or liquid petroleum gas, and there is ethanol. All of them can be purchased on a standardized level, and so we thought about how to use them. And we looked into some of the fuel cell systems available on the market, and found out that the fuel cell systems available on the market have some different consumptions and have some different, let's say, requirements to the fuel. There are fuel cell systems available based on hydrogen. There are fuel cell systems available based on methanol, and fuel cell systems based on liquid petroleum gas. And we have some own developments in terms of fuel cell systems that can be operated on methanol or on ethanol. Now, if you look into the actual annual fuel consumption of a 1 kilowatt net power fuel cell system, and you look into the hydrogen supply, you see that depending on the amount of runtime you have to cover annually, you come into the supply of quite a few hydrogen cylinders, which might pose some logistic problems. While when you're moving towards liquid fuels like methanol, or when you're moving towards liquid fuels like ethanol or gaseous fuels like liquid petroleum gas, you can significantly save on logistics cost and logistics effort. And so if you look at the processing of carbon-based fuels, you have to look into, first of all, the fuel. You have, in some cases, the desulfurization, particularly on the liquid petroleum gas. You have to look at the reforming, then at the gas cleaning, and finally at the fuel cell, if you're not able to run the fuel directly, like methanol. So if you look at the fuel composition, you have to take into account that fuel processing takes place at different temperatures, for example, and with different effort. So basically, if you're using liquid petroleum gas, you have to make sure that you can desulfurize the fuel, since liquid petroleum gas is odorized, and this makes some extra effort into the fuel processing unit. If you look into methanol, you can either use it directly, and I think the next speaker will talk about that, about the benefits of using methanol directly. But once, let's say, the power gets larger, one considers maybe processing of methanol is an appropriate option to use a liquid fuel in a fuel cell system. And the benefit of processing methanol is that you can operate it on rather low temperature. So below about 300 degrees, methanol already can be decomposed into a hydrogen-containing gas. If you're looking into higher hydrocarbons, if you're looking into higher alcohols, then you have to take into account that fuel processing somehow goes up to 700 degrees centigrade with all, let's say, the subsequent challenges to turn carbon monoxide, which naturally is generated under these conditions, into hydrogen again. So besides this, there is a general challenge in reforming fuels, is maintaining the water balance, or let's say providing water for reforming. Now, there is a benefit in using alcohols as a fuel, since you can make up for water losses by providing diluted alcohols as the fuel for the fuel cell system. Now, we started to investigate some methanol reforming system at ZSW. It's an Autothermal system. It's basically functionally integrated reforming, preheating, and then subsequent reactor of CO cleaning. You see here the system as it is shown on this image. It has a reformer stack. It has some evaporator unit and integrated into the reformer stack, and it has some CO cleaning unit. And basically this is the key unit, the reformer, including the evaporator. It decomposes into sort of a plate-light reactor, and it pretty much, from an assembly point of view, looks like a fuel cell, so it suits us rather well. And you can basically operate it. We did a prototype, and we could see and to operate it in a way that we can produce CO levels which are compatible with low temperature PEM fuel cells. We could see that it starts and stops. We could see that it basically works, and we could verify that in a further technical development option it might well meet the requirements that are set out for a fuel cell system that's out in the field. This gives some packaging studies. So in total, at its current stage, it packs into a 45-liter packing volume, and with some optimization on the piping and with some optimization on the reactor design, we are confident to pack it into something like a 25 to 30 liters volume. Now, still, with the fuel cell system, there is a CO challenge, and we have to meet the CO challenge somehow, either by using CO-tolerant fuel cells, which we are currently doing, using a CO-tolerant fuel cell that can tolerate up to something like 10 ppm CO. But another challenge remains what to do with the unspent fuel in the CO-tolerant fuel cell. And in this case, we can tune the turnovers in a way that the unspent fuel can be used to evaporate water and methanol for the reforming reaction. It's an autothermal reformer. The autothermal reformer allows a fast startup. However, it has limitations to make use of the spent fuel. And so let's say if we want to make better use of the spent fuel and operate the fuel cell stack in a more optimized way, we could go to a steam reforming as an option. And one option in this case is the steam reforming of ethanol. We realized that in a 1 kilowatt system, which we had on show last year on this fair. And we also were able to integrate a reforming system that has a gas quality below 10 ppm of CO, and that basically drove the whole system with an integrated ethanol supply of some 5 liters, which allowed operation for several hours, or up to a day. So as a conclusion, especially if we are looking into high power demand and long grid outages and long operating times, the supply of gaseous hydrogen is posing a logistic and a cost challenge, obviously. Fuel cell systems with an integrated gas processing technology are addressing this issue. Methanol is one good option to provide lightweight and easy processable fuel. It can be reformed at low temperatures. It survives with a single stage CO cleaning unit, and if operated autothermally, it offers fast startup possibilities, however with limited options to make use of unspent hydrogen. Methanol as a chemical is inexpensive, but methanol is a chemical and has to be handled in a way that the user does not get into contact. And even methanol water mixtures are available commercially at the market. Propane and ethanol are excellent alternatives. They're also available on a widespread wholesale basis and individual sale basis. And so in general, if the challenge of the fuel cell system is long duration, then liquid fuels and fuels other than hydrogen pose a good option to cover that. Thank you.
Very much. Thank you for this shorting presentation. So this is your applause, Mr. So this time we have. So thank you very much. If there are some questions, I think you will stay here for some minutes, and afterwards you will find Professor Jörissen at D booth at D50 at the booth D50 here, and all the slides you find in the internet, it's at the back of this brochure. So thank you very much, Mr. Jörissen, and we will continue directly with the next topic, 3,000 EFOY fuel cells in operation worldwide, by the head of sales SFC Energy, Christian Böhm. Thank you.
Yeah, good afternoon. Welcome here to the stage. And just to let you know, the first time I was here at the Hannover Fair was 2003, so 11 years later. My presentation will be around 30,000 EFOY fuel cells in operation worldwide. And I'd like to discuss with you and explain to you about the details, how to get from a prototype that we have shown here in 2003 to a significant number of fielded fuel cells in operation. First off, our company SFC Energy is 14 years in business, as I said. It is has 246 employees in 4 locations worldwide, and I'll show you on a map later on where that is. We have fielded, as the title says, 30,000 fuel cells so far. And we also understand that this is the transition that SFC has gone through from focusing on the fuel cell technology to the fuel cell product that you see here on the left side, to integrating the product into a full product solution, including the service that SFC provides by itself, but also through partners worldwide, to have a reliable product for the customers. To get there, number one is a robust technology. SFC believes in its power range on DMFC technology. We heard in the previous presentations about the technology. SFC does have a strong IP portfolio as a base on. 33 patents have been granted, and you see a few of those inside the system regarding the stack, water management, also the fuel cartridge, and I'll talk about that later on. Also very important and very significant are the certificates that we have gone through to meet industry standards and to enable the fuel cell to be accepted on the market and to be applicable for the applications worldwide. This slide I like a lot because it shows in one slide what it means to have a very easy to handle and safe to transport fuel. On this slide you see the little girl on the left side here carrying one of our standard cartridges, 10 liters of fuel that has an energy density or the energy content of 11 kilowatt hours. And just as an example, on the right side you see the same amount of energy stored in conventional lead acid batteries of 270 kilos. So that on one slide explained to you what the key benefit of the fuel cell using methanol as a high energy density fuel is. And that is based, this bases on this fact, the success story of the EFOY fuel cell is based on. Another key success factor for SFC was a platform strategy that we have chosen. Some of you might know that one of our key markets is the consumer market. That's motorhomes and sailing boats that you see in the middle of the slide here. More and more importantly is for us the industrial market, where high reliability and sustainability are key factors for off-grid power. But also for on the defense side, we have product solutions, which we call the Emily here, for very harsh and ruggedized environment. The keynote here for this slide is that in combining all these different markets based on one platform, we were able to achieve a very high system reliability and also benefit of the economy of scales, because the core parts of the fuel cell, the stack, and the surrounding components, balance of plant, are based on similar designs, and with that factor we could achieve the economy of scales for that product. Worldwide distribution, you see on this map here SFC's headquarter based south of Munich, Germany. We do have operations in Almelo in the Netherlands and in Romania, in Cluj, and very new as of last year also in Calgary in Canada for the oil and gas business. The green dots on the map here show the partners we have. You see, of course, focused here on Europe, US, but also in Asia. We have increasing markets where the fuel cell is used, and very importantly also to support the product, the fuel infrastructure is important. So all these dots here, the fuel cartridges that you see here on the stage are available for the products. There is also some key customers on the lower side of the slide that show where the fuel cells are actually used and where they deployed. Yeah, overall, 30,000 fuel cells have been deployed so far. I brought to you today in one slide several of the applications that I go over real quick. As I mentioned in the beginning, the leisure or consumer market was our first mass market where we could actually achieve significant numbers, production rate numbers, and also sailing boats. We also see applications along railways here, automotive on the highways, parking systems, very often also security applications where the fuel cell with our power level matches very well to the power demand of electronic cameras. And a growing market for us is also the oil and gas, where per definition you face an off-grid situation, and there a fuel cell that is supporting instrumentation, cameras, also security applications is of course a very nice application. yeah, with that, and knowing that you want me to come to an end, I'd like to thank you for your for coming here today. And unfortunately, we do not have a booth here, but I'll stay around here. And my colleague is so kind, in case you have interest in the product, in the company, to get one of those brochures. Thank you very much.
Thank you very much.